Welcome back, students taking Math for Business and Finance and Math Applications, and we're working on the Chapter 13 Summary Practice Test. And we only have 3 more problems to go through, but they are just slightly a little bit more difficult. So let's see if we can't get through them. Okay, so Summary Practice Test number 8. All right. Scupper Molly invested $1,800 semi-annually for 23 years at 8% compounded semi-annually. So what does the value of this annuity do? Okay, this problem is basically just like problem number 7. All right. Remember, for an annuity due, it's the number of periods plus 1. Then we get the factor and multiply it times the payment amount. And then whatever we get for that, we subtract 1 payment, and that gives us the value of the annuity due. So if I have 23 years at compounded semi-annually, that gives me 46 periods, but I have to add 1, which means I'm going to look up 47 periods. And 8% interest divided by 2 means I'm going to be looking up 4%. So I know that there's no 47 periods on the chart, so go into your business math handbook and look up that factor, okay? And pause, to make sure that you're finding the factor first, and then come back and double check it. And if you did that, you end up with a factor of 132,942, okay? And you multiply that factor, right? So remember, this here was step number 1, okay? This is like number 2, right? So this is 1 here. This is number 2. So we multiply by the factor, the 1,800, and we end up with 239,301.36, okay? And then so for step number 3 here, we subtract out 1 payment, okay? And so we subtract out $1,800, and that gives us the value of the annuity due, which is 237,501.36. Okay. Again, problem number 7 is identical to this one, so go back to that video if you need a watch, or one of the other ones in the drill and word problems. Okay, number 9. Okay. All right. Nelson Collins decided to retire to Canada in 10 years. What amount should Nelson deposit so that he will be able to withdraw $80,000 at the end of each year for 25 years after he retires? Assume Nelson can invest at 7%, compounded annually. Okay, so this problem was similar to problems 1329 and 1327, the word problems. All right. So if you want to go back and watch those videos, those 2 particular problems, they're very, very similar to this. So I'm just going to work through the problem instead of talking a lot about the theory. So I want to know how much he needs to invest today. He's going to retire in 10 years. And then he wants to, over the course of the next 25 years, be able to withdraw $80,000 at the end of each year for the 25 years. And the interest rate is at 7%. Okay, so we're going to, and it's compounded annually, so we're going to look up the factor, the present value, because we want to know what value of the annuity is when it begins to take effect. All right, we're working this problem backwards. Okay, we need to know, we need to be able to have a lump sum at this point in time, at the 10-year mark, and be able to find the present value of that lump sum. But before we can do that, we have to find how much we need here for that lump sum. So in order to be able to have the $80,000 for 25 years. So we're looking at the present value, and we're going to look up on the chart. You have to go to the Business Math Handbook, and you're going to look up 25 periods at 7%. And let me jump up and see. Let's see, 7%, 25 periods. Okay, 7%, 25 periods, 11.6536. So the factor is 11.6536, and I'm multiplying that times 80,000. That gives me 48, 4, 24, 28, 2, 42, 48, 52, 5, 13, 9, 32, 288, 1, 2, 3, 4. So I need a lump sum of $932,288 at this 10-year mark. Okay. Now that's not the amount I need today. I mean, because I'm going, what we're asking is how much do we need to deposit today, but as a lump sum so that it can accrue over the course of the 10-year period before he begins to retire. So we're talking about the present value of a lump sum, right? And so we're going to end up using table 12.3, okay? And we're going to look up in that table, 10 periods, all right, at 7%, and we're going to find that that factor is 0.5083. So we can take the 932,288, and we're multiplying that by 0.5083. Okay, and then that gives us an amount of 473,881.99, which is the amount that needs to be invested today, right, as a lump sum at 7% for 10 years, so that at the beginning, at the end of 10 years, during the course of the next 25 years, he can withdraw $80,000 that's still earning at 7%. Okay. Okay, again, go back to look at problems 1329 and 1327. If that's a little unclear, I know that in 27, I believe I actually went over it a couple times in order to try to make sure that the theory is, stands out in your mind. Okay. All right, last problem here. Bob Ryan made deposits of $10,000 at the end of each quarter to Lion Bank, which pays 8% interest compounded quarterly. After 9 years, Bob made no more deposits. What will be the account's balance 4 years after the last deposit? Right, so this is kind of like the opposite of the previous problem. In the previous problem, we were saying, here's a lump sum, and then, and it's going to accrue over this time. We're going to get interest over this time, and whatever that dollar value is here, we're going to keep it as an annuity, and we're going to take payments on it over the course of X number of years. Well, this one here is sort of like the opposite, being that he's going to make deposits. Okay, so we're going to start here, and he's going to make deposits quarterly for 9 years. All right, so that's 9 years times 4 quarters is equal to 36 periods, and he's making $10,000 quarterly deposits over the course of the 9 years. Okay. Now, he's getting interest at 8%, and that's compounded quarterly, so we divide by 4. That means it's 2% interest per quarter. So with that said, okay, so now what we want to do is we want to know how much it is at this point in time, all right? So we're going to look at look at this from a perspective of an ordinary annuity. Okay, so we want to know what the the value of this ordinary annuity is at the end of 9 years, and then that whatever amount that is becomes a lump sum, okay, for another period of 4 years. So first off, let's work on the annuity. So when we look at the ordinary annuity and go to your business math handbook and look up 36 periods at 2%, you find that the factor is 51.9942, and we're going to multiply that by 10,000, and that means we end up with 519,942 is how much would be in the account at the end of 9 years. Okay, so we have 519,942 at the end of 9 years, and that's, remember, that's a lump sum, and that's going to sit there for an additional 4 more years. Okay, so no more payments are made over the course of 4 more years, but it's still at 8% interest, compounded quarterly. So for the 4 years, right, times 4 periods is 16 periods, and we're still at 2% for the compounding. And we need to look up, and you can go to table 12.1, which is the future value of a lump sum. Right? Remember, when I say lump sum, and the table says future value of $1. Okay. So when I go and I look up that factor, I find that the factor is 1.3728. And so I multiply the 519,942 times the 1.3728, and he will have $713,776.37 at the end of that period. Okay. All right, so if you had gotten that, go ahead and pause the video or stop the video, but I'm going to just quickly go over it again. If you need a little bit of a refresher in order to understand, go ahead and continue to watch this video as I erase all of this. I'm just going to quickly go over it again. Okay. Let me get rid of this. And the reason why I'm going over this is because this is the opposite of what we did in that last problem. Okay. Right, so it's saying, and it always helps to draw out a timeline. He's going to make deposits of $10,000 at the end of each quarter, which pays 8% interest. So 8% divided by 4 is 2% compounded quarterly, and that's going to be for 9 years. Well, 9 years times 4 is 36 periods that he's putting $10,000 in for each and every one of those periods. So he's making these payments of $10,000, so that's an annuity, all right? And we're looking at an ordinary annuity, all right? And we want to know what that future value is. So when we look up that factor, we end up with a factor of 51.9942, and that's going to be times the 10,000. So at the end of that period, at the end of the 9 years, the future value of that annuity is going to be 519,942, but it's going to sit there for an additional 4 more years. Okay, so sitting there for the additional 4 years, that's an additional 16 periods, and it's still at 2% interest. So that lump sum of 519,942, we want to know what the future value of the lump sum is. And again, this is from chapter 12, table 12.1. Right? And you can look up the factor and find that the factor is 1.3728. And when you multiply that out, you end up with 713,776.37 is the value of those annuities at the end of that 4 years. Okay. Right. Well, that's it for chapter 13. And as always, if you didn't understand something, rewind and watch the videos again. And if you have any additional questions, feel free to contact an instructor. Okay?